Welcome back to Chapter 5, Section 3, Formative Assessment. We're going to thoroughly discuss the main questions of Chapter 5, Section 3. The first question: state the general period and group trend among main group elements with respect to each of the following properties. And atomic radius. So last time when we defined atomic radius, we defined half distance between the two equal-sized atoms. So if we have A, we define atomic size is the distance, half a distance between two similar atomic size. So half a distance. Why we couldn't define atomic radius from a single atom? Because we have already said an atom has a wave. So we don't know the age of the last age of the wave, because we are not sure about the age, at what point the density of electron extends. For this reason, we are not going to use a single atom to define atomic radius. So atomic radius is half the distance between the two nucleus, half of the distance between here to here, which is half of it. So to answer the first question, it says the general periodic trend. So the periodic trend is somewhat atomic radius. So generally, for question number 1, atomic radius generally decreases generally decreases across periods and increases down groups. We have already outlined why this happened, because as you go across a period, electrons are added in the same shell, so the nuclear charge is more dominant than the size, the electron repulsive. So it will shrink the size. So generally, bear in mind, this is a general trend, because there are some elements, radius or atomic radius, which doesn't obey this phenomena. So generally, it's a general, not all of them will decrease. The general trend decreases across a period and increases down groups. B, 1b, again, first ionization energy. So first ionization energy generally increases across periods and decreases down groups. What does it mean? So if you see ionization energy, especially first ionization, which means we do have second ionization, third ionization. So ionization energy is the energy required to remove electron from the atom. So after what kind of atom do have high ionization energy? Having a nuclear charge, bigger, a smaller size. So we have to relate this thing. So first ionization energy, as you go across a period, generally increases across a period and decreases down a group, because down a group, why it decreases? As you go down a periodic table, new shells are coming, so the size of an atom increases. So we can easily ionize the electron from the atom. So the first ionization energy follows this general pattern. When we come to phi, the trend, we are now expecting electron affinity generally increases generally increases across periods among groups among groups 13 to 17 and decreases down groups but many exceptions are observed. So we have to highlight again the main points of this part. It says generally increase across periods among groups and decrease down a group. So, but many exceptions are there. That's why we say generally. So what is electron affinity? The tendency of an atom to acquire electron so that it will be negatively charged ion. So to do this, energy is involved. Either energy is added or removed. So in most cases, electron affinity is energy is given off because it's a payment of energy in order to acquire electron. So to acquire easily, the size has the electron affinity is greater. So that as you go across a period, electron affinity increases. Down a group decreases. Next one. Generally, the second one, D, ionic radius. Ionic radius means if an atom gains or loses, the neutral atom become an ion. So generally decreases across periods and increases down groups. So ionic radius generally decreases across periods, increases down in groups. So if you see all atomic radius for ionization, electron affinity, ionic radius, all of them except electron affinity decrease across a period. Generally decreases across periods, increases down groups. So the next one is E. Generally increases electronegativity. First we have to define again, to refresh your memory. Electronegativity is the power of attracting electrons towards the atom during bonding in a chemical reaction, when in a molecule formation or a compound formation. So the more electronegative ones withdraw more electrons towards themselves, so that they will make the molecule unequally shared. So electronegative species are those, the highest electronegative are fluorine, oxygen, nitrogen. So you will find them in the right part of the periodic table. So gradually increases. gradually increases across periods and uh, and either decrease either decreases or remains about the same. Remains about the same. Down grows. So this is the first question uh, about the trends, periodic trends in atomic ready, first ionization, electron affinity, anionic ready, electronegativity. So we'll see in the next question what first ionization is, second ionization, and third ionization. Uh, let's go to the next question. In general, how do the periodic properties of the d block elements compare with those of the main group elements? To begin with 2a, they vary less and with less regularity than main group elements do. So the first question, in general, how do the periodic properties of d block elements compare with those of the main group elements? Uh, they vary less. Why it is vary? Because the S and P block, we call them representative elements because it represents different kinds of elements. So they vary as you go across a period. But unlike that one, the variation is very less, and the regularity is also less. So it's regular. The regularity is the periodic nature in S and P is higher than the periodic nature of D block. So it's less regular. So second 2b, explain the comparison made in A. Okay. The difference is generally attributed to the presence of electrons in incompletely filled d sublevel. So the difference is generally attributed to the presence of electrons in incompletely filled d sublevel in atoms of the d block, of the d block, the d block elements. So the difference is generally attributed to the presence of electrons in incompletely filled d sublevel in atoms of the d block elements. So the variation, less regularity and very less, the variation with each other is very less, and the regularity is also very less. The reason is the difference is generally attributed to the presence of electrons in incompletely filled d sublevel. So when it comes to question number 3, for groups 1 and 2, for each main group element, what is the relationship between its group number and the number of valence electrons that group numbers have? 3. For groups 1 and 2, for groups 1 and 2, the number of valence electrons, valence electron is equal to the group number, For groups 13 to 18, the number of valence electrons is equal to the group number minus 10. So in our description last time, we have seen for the main group, for each main group element, what is the relation between its group number. The last electron in configuration in the outermost shell will represent the group number. If in the outermost shell there are 5 electrons, it is group 5, and it is 6. But in relationship with for group 1 and 2, for groups 13 to 18, which is the P block, to find the group number, simply subtract 10 from the group number. So you will relate according to this one. So question number 4. Relating ID's graph, the general trend is left to the right. So this simply by drawing we can see, we can have this relation. So we have this graph, second ionization energy, and this is the atomic number. Let's assign atomic number 1, atomic number, let's have 5, let's have 10, and let's have 15, and let's have 20. So this is atomic number versus ionization in second ionization energy for different elements. So we have this kind of behavior in So if you can see helium over here, then lithium, then lithium, beryllium, sodium, 3b sodium, and magnesium, potassium, and calcium. So from this, what can you conclude? Second ionization energy, as we have said, is more stronger than first ionization energy, because once you ionize in the first ionization energy, always first ionization energy is much easier than the second ionization energy. Second ionization energy, and second ionization energy is easier than third ionization energy because the first part, removing an electron from an atom, needs little energy as compared to the second one. Why the second one is more stronger than the first one? Because when electron is removed, the nuclear charge is more powerful than ever before. So this makes the second ionization energy stronger. It needs more energy to ionize. And you can give the same reason for third ionization energy. So generally speaking, second ionization energy, as you go across a period, decreases.